Hello everyone. In this session, we are conducting an experiment on frequency response of a second order system. So the aim of the experiment is to determine the frequency response of a second order system and also to evaluate the frequency domain specification. So what actually the frequency response means? When the steady state, it is actually a steady state response of a system to a sinusoidal input. So now let us consider one LTI system, that is linear time invariant system. So for this system, if you give a sinusoidal input, it may be sine of omega t, or you can consider it may be cos of omega t. So you are going to produce a sinusoidal output, but the output will be, it won't be same in magnitude and phase. Let us consider the output will be a of sine of omega t plus phi. So this is what we call it as a frequency response. When you give a sinusoidal input to the system, you're going to produce a sinusoidal output with a change in magnitude and phase, but the frequency will be remains the same. So this is what we call it as a frequency response of a second order system. So now in this experiment, this is the circuit diagram for conduction of the frequency response. So here we have considered series RLC circuit. So in this we are going to keep on vary the frequency and keeping all the parameter constant. So this is the input supply 2 voltage peak to peak, that this we are taking it from the signal generator. The resistance which we required is 400 ohm, inductance required is 100 millihenry, and the capacitance is 0.1 microfarad. So across the capacitor we are going to measure the output voltage. So this is the frequency domain characteristics of the frequency response experiment. So on the x-axis we have a frequency, and on the y-axis we have the gain, that is AV in decibel it is. So from this frequency response, so what we can understood is, so this is the resonant peak in gain. So that indicates that this will be the maximum voltage across the capacitor. So at this particular frequency, consider it as a resonant frequency FR. So we are going to get a maximum voltage across the capacitor. So this value is also depends upon the damping factor which has been in the circuit. So now we'll see the experimental setup for the conduction of this experiment. So this is the experimental setup. So here we have taken a resistor which is having a 390 value. Either you can take a decade resistance box also. Then we have a decade inductance box is there. Then we have taken 0.1 microfarad capacitor. So these are the parameters for our experiment, and it is all connected in the discrete form. And here we have connected one multimeter across the capacitor. So parallel to the capacitor we have connected one multimeter. Now for the in series with the resistor, we are connected to the signal generator for providing a 2 voltage peak to peak. So here we have already set the 2 voltage peak to peak. So that is being given to the circuit. So this is the theoretical calculation for frequency domain specification. So these are the equation. Since the values of L and C and even R value is also known from the series RLC circuit. So we have calculated omega n value, zeta value, omega R, the resonant frequency, and R again it has been we have obtained as 400 ohm only. So one thing you need to observe, so we are going to consider this resonating frequency as equation 1. So why? Because in our practical conduction we need to prove that at this particular frequency, that is the frequency will be equal to 1.5 kilohertz, we need to get a maximum voltage across the capacitor. So at this particular frequency only we need to obtain a maximum voltage across capacitor. So that is what your experiment is. So consider this equation as your theoretical equation. So now coming to the tabular column. So this is the tabular column for conduction of this experiment. The input voltage we have considered is 2 volt, and this is the RMS voltage, and this is for the gain calculation. So here we have 4 tabular columns, or 4 columns are there. So in the first column we will be taking the frequency, then V0 RMS. This we are going to measure it by using a multimeter connecting in parallel to the capacitor. And after measurement of only these 2 readings we need to take it from the experiment. After that these 2 part will be the calculation. So now we can start taking the frequency from 100 hertz, even from 200 also we can start with the change of, with the increasing of 100 frequency, and we need to continue taking up the readings, and also V naught across the output voltage across the capacitor also need to be measured. We need to continue this more than a frequency of 1.5 hertz, 155 kilohertz. So now in this experiment we are going to keep on vary the frequency value starting from 200 up to 2 kilohertz. Then we need to note down what will be the output voltage across the capacitor. So the first reading here I have set the frequency to 200 hertz, and this is the voltage across the capacitor, that is 0.5. So these two readings we need to note down. After noting down these two values, next similarly increase the frequency as 300. So in the increasing of 100 we need to take the readings. So next we need to increase the frequency to 300. So now after repeating the same procedure, so here I have taken increasing of 200. Similarly you can increase take up the readings by increasing of 100 also. So for 200 I have received the voltage on the output side as 0.77. So it will be keeps on increases. Similarly observe here for a 1.4 kilohertz or 1400 hertz we have obtained the maximum voltage as 1.63 volts. Again for 1.6 kilovolt or 1600 volt, so hertz, the voltage will be again reduced to 1.19. So now what does it indicates means we are receiving a maximum voltage at a frequency of 1.63. So now this will be our practical values. So observe here, this is our theoretical value at a frequency of 1.5 hertz we are getting the maximum voltage, but in our practical calculations, so here at a frequency of 1400 we are receiving a maximum voltage on the output side. So the theoretical value and the practical value, it is almost the same, so we can consider that the frequency response of the theoretical and practical will be the same. So after that we need to measure the V naught by V in value, and also we need to measure the gain value by using this formula. So once the tabular column is complete, then we need to plot the graph in a semi-log sheet. So this is the graph after the completion of tabular column. So here on the x-axis we are taken the frequency, and on the y-axis we have taken the voltage gain. So at this particular frequency we are getting a maximum voltage. So this frequency we call it as a resonant frequency. So from the theoretical value we have obtained FR, the resonating frequency will be equal to 1.52 kilohertz, but from the practical we have obtained the resonating frequency value as 1.4 kilohertz it is. So that we can consider the theoretical calculation will be equal to the practical result. Thank you.